In this video, I'll poorly explain what a Riemann surface is, named after its founder.
Bernhard Riemann.
First, we need to talk about what complex numbers are. Remember way back when we learned the number line? Here we are. This number line has numbers like 1, 2, a billion, fractions like a half, 5/3, and even numbers that can't be written like a fraction like pi and e. So what we're going to do now is take another copy of this number line, rotate it 90 degrees, make it go up and down, and paste that shit in the center, and add I next to all the numbers. This is what we call the complex plane. Some of you might remember that I was that funny little number that equals square root of -1, and if you don't, then... Okay, so the complex plane contains numbers like 1 plus I, 5 minus 2i, and pi plus square root of 2i, etc., etc. You can see these numbers are like standard coordinates where the horizontal axis is the real part and the vertical axis is the imaginary part. So the complex plane is pretty cool because we can do fun stuff like calculus on it, and there's a lot of interesting results that come out of it, but this is a whole field that deserves its own video, so I won't dive into it here. But eventually doing calculus on this complex plane gets old and stale, like your mom. So this is where Riemann surfaces come in. A Riemann surface is, well, first of all, a surface, like this piece of paper, this sphere, or this SpongeBob ice cream. Hell, you are even a surface. Basically, a surface is anything that lives in a 3D world. Better yet, it's a surface filled with points of complex numbers. For example, look at the sphere. We can say that this point is 1 plus I, this point is 0, and etc., etc. Having points like this allows Riemann surfaces to have some mathematical significance, and one of them is this. So for the sake of example, we're going to be working on the sphere. Spoiler warning, the sphere is actually a Riemann surface. Okay, now look at any point on the sphere, and this is now going to be our new origin point, or you can think of it as our new point of reference. Now what we're going to do is zoom in really close into that point. Okay, that looks pretty good. Now once we have zoomed in really close to this point, we actually get something that looks like a snippet of a complex plane, with our point being the origin. And this is why we called this point like our new origin point or our point of reference. Now, because it looks like the complex plane and we can do calculus on the plane, this means that now we have a nice way of doing calculus on these wacky surfaces, and better yet, most of the nice results from ordinary calculus translate over smoothly. Well, that's basically what a Riemann surface is, a surface that looks like the complex plane zoomed in real close. Well, there's actually a lot more conditions, like these, but those are like formalities, and I won't get into it here. Now you might be saying, so what? This is just abstract nonsense, and I don't want you to ever talk to me nor my family ever again. And I say to you, oh, I actually just looked this up, and it seems Riemann surfaces are used in general relativity and quantum mechanics and like other stuff in physics. So yeah, it's pretty. Now that Riemann surfaces has earned its math clout, let's look at some of my favorites. We already saw this one, it's the sphere. This sphere is actually so special that it has its own name called the Riemann sphere, for obvious reasons. Oh, and then there's this donut looking thing called a torus, singular for tori. And there's this twirly looking boy too. Actually, we even started this video with the Riemann surface. Remember the complex plane? Yeah, that's a Riemann surface too. We don't even need to zoom in to see that the complex plane looks like the complex plane. Well, that's it. Obviously, this is a very simple explanation, and one can waste many years of their life studying these things, like me. But if you ever want to learn more about it, just go to the wiki or NLab. Okay, bye.